Middle School Math PLC began looking at data to drive their goals for 2017-2018. We considered the following questions. What do we want students to learn? How will we know if they have learned? What will we do if they don't learn? What will we do if they already know it? We looked at the data to determine areas of student need. When looking at the evidence statements related to areas of weakness, we realized that students were able to solve these problems in isolation. However, when mixed with other topics and words, the struggle became evident. At first, when thinking of a goal, we thought the main problem was that students did not know the appropriate operations in solving problems. They simply did not know where to start or what was being asked of them. Our initial goal was, by the end of May, 80% of students who scored 6 or less on the conceptual understanding of mathematical assessments will demonstrate an increase in ability to recognize appropriate operations required to successfully solve multi-step word problems by 2 questions or more. We then created a 10-question assessment to administer to all students in grades 6 through 8. The assessment consisted of understanding they had to select multiple responses, identify error, or identify what operation was needed to begin solving the problem. After analyzing the results, much to our surprise, approximately 25 students, or 15% of the population that took the assessment, fell below the cutoff of 60% or lower. We realized that this assessment data was not representative of our population. Many more students struggle than the results showed. We had to go back to the drawing board and think of a more realistic goal. We then decided to analyze Type 2 and Type 3 PARCC questions at each grade level. Students were given 3 questions. Students were asked to complete the 3 problems to the best of their ability. These results were eye-opening and helped our PLC drive instruction and determine the steps needed within each classroom to adjust instruction in order to help these students achieve success. We then adjusted our student goal. Our new student goal was, by the end of May, 80% of students who earned 50% or less possible points on the multi-part mathematical problems will demonstrate an increase in ability to recognize appropriate conceptual understanding required to successfully solve multi-step word problems. Our educator goal remained the same. Our educator goal was, educator will learn and incorporate a variety of differentiation strategies to address weaknesses in identifying the appropriate strategy required to demonstrate conceptual understanding required in problem solving. The teacher had to adjust their practice in order to give the students the tools they need to achieve the student goal. We will take a look at each grade level to see how the teacher adjusts their practice to help students achieve success.
As you can see from our presentation, the mathematics section for the PARCC assessment consists of a variety of problems, and they are broken down into types. Type 1 questions are right or wrong and can be automatically scored. However, types 2 and 3 require students to think critically while solving rigorous mathematical problems while explaining their thinking and thought processes. These problems are scored using a rubric and require multiple steps to receive full credit. They require accurate computational skills, as well as modeling and reasoning skills. So, after our PLC reviewed the evidence from statements from last year's PARCC results and honed in on each grade level's weakest strands, we incorporated classroom strategies to specifically address those type 2 and 3 problems. All of the middle school math classes focused on regular and consistent spiral review, activities which address computational skills in daily lessons, including do-nows, homework, error analysis problems, and other assignments. After our PLC refocused our goal to increasing students' ability to effectively respond to these higher level questions to not only solve problems correctly, but to also respond to all parts of the problems with the proper modeling techniques and reasoning methods required, we adjusted our classroom practices to focus on differentiation strategies that would address these deficits, including chunking, identifying unknown terms, highlighting and drawing pictures. Most importantly, we practiced with our students to use a 4-step method that included rereading the problems and checking back over the responses to see if they were reasonable and made sense and answered all parts of the question. After targeting each grade level's problem areas and addressing methods and techniques to increase our student outcomes, we did show growth when students encountered these types of problems in their final responses. Thank you.